Hey, what's going on? It's Mr. Sanchez here, coming at you with another lesson for Algebra 1. Today we're going to go over lesson 5-2, domain and range. We're also going to cover a little bit of function notation because we're not going to spend a lot of time memorizing all of that. For our learning targets for today are going to be describe the domain and range of a function and find input-output pairs of a function. Okay, now if you remember from last class of last lesson, 5-1, functions any relation that where each input has exactly one output. Okay, but we do have new words. We're talking about domain and range today. So what is that? Well, domain is the set of all inputs for a function, and range would be the set of all outputs for a function. All right, input outputs. So there's a difference, and I'm gonna show you guys how to find the domain and range of a set. Okay. So whenever we have a function like this, right? It's going to be x. The first value is always going to be x. The second value is always going to be y, right? Well, in this case, all your x values, those are going to be your inputs, right? And all your inputs are going to be what's the word? All the inputs are going to be your domain because input domain, right? Think about it, x. All right. So what we do, we're gonna write, since it's a set, you're gonna use set notation. So you gotta use the curly brace, and you're gonna put all these values in here. So -7, and I'll use red for this. So -7, 9, and -6. These numbers here, all these numbers, these are your inputs. And so all your inputs are always going to be your domain. All right. Think about it like this. If I have an input, that goes with the domain. Input domain. All right. When it comes to range, the range is the set of all outputs for a function. So in our case, the outputs are always going to be the y values. Okay. So let's see here. Zeros are y value, -3s are y value, and 2.5s are y value. So we can safely say that our range is going to be the 0, -3, and 2.5. And we'll write that in here. So it's going to be 0, -3, and 2.5. Okay, and then we'll close the parentheses. All right, and that's going to be our domain. Our range. Our range is always our outputs, right? So whenever you hear the word output or domain or range, remember output, range, output. Domain is inputs, and range is outputs of a function. Okay. And that's pretty straightforward. You gotta find what your inputs are. It's all x values are almost always our inputs, and the y values are always our outputs. All right, so let's look at this. Let's look at this table. That's a function, right? And we'll find our inputs and our outputs in our domain and range. All right, so let's look for our domain first. Our domain is always the inputs, right? So all these values here are gonna be our domain. So for D here, we're gonna put our domain, and I'm gonna use red. Our domain is the number 7, the number 3, and the numbers 5. That's our domain. And then if you look at what a range is the outputs of a function, right? So outputs, that means it's going to be this column, all right? So when we write our answer, our range is going to be all the numbers in the output column. So it's going to be 6, -2, and 1. Right, so all these numbers here are our range. And it would be the same thing if you had a mapping. If you had a mapping, where it goes like 1, 2, and then 5 and 6, and it goes like that. Well, this is our input, and these are our outputs, right? So the domain here would be 1, 2, because it's our input, and our range would be our output. So that would be 5, 6. And remember, we're using the curly brace. Why? Because we're not doing ordered pairs. Okay. And if you had a table, if you had a plot of points, then all you have to do is find the points. Like, if it's 3 comma 4, 4 comma 5, and 5 comma 2, then our x values are going to be our domain, and then our y values are going to be our range. Very similar to over here. Okay. All right. So that's the domain and range in a nutshell. Inputs are the domain. Output is going to be the range. All right. Now in math, we have something crazy that we like to call function machines. What's a machine? All right. So this here is our function, right? Our function 2x plus 5. All right. If you think about it like a vending machine, this 2x plus 5 is a vending machine, and so if you put a quarter, in this case a value for x, so if you put this inside, then it's going to give you a y value in return. Okay, so what's that y? So it's so basically when they ask you what is the output if the input is x equal to 7. So what we're saying is we're going to put this 7 here, so this 7 is going to come in here where the x is. So we're going to rewrite this as 2 times 7 plus 5. We're evaluating, okay? So 2 plus 7, 2 times 7 is 14 plus 5. Okay, so that's going to give us the answer is going to be 19 here, okay? So and yeah, that's basically it. All right, so what is the output if the input x equals -2? So instead of having 7 here, right, so instead of having 7, we're going to have -2. And I'll put that in red. So we're going to have -2. And you're plugging that in for all the x's in here. All right, so you're going to have 2 times -2 plus 5. What does that equal? 2 times -2 is going to be -4 plus 5, which is going to give us the answer is 1. All right. All right, so once this, and I need to give myself a little bit more space. Give me 1 second. Let me just give myself some space because we're not going to cover this yet. All right, so in math, we like giving sometimes the book is going to ask you guys give the answers in input output ordered pairs, and all that really means is what's your input. Okay, so you're going to write an ordered pair. First, you're going to put your input. In this case, our input was 7, right? What was our output when we plugged in 7? Well, when we plugged in 7, we got 19. Okay, and that's our input output pair for the first one. All right. Now for this one, for the second one, our input was actually -2, right? And what was our output when we had -2? It gave us the answer of 1, right? So we're going to put our output as 1. And this is our other input output pairs. When it says give your answers as input output ordered pairs, inputs are x value, outputs are y value, right? And one thing you'll notice is drawing this machine thing here is kind of awkward, and we don't really like doing that in math. I mean, we'll do it, but we rarely like to do that. So what we like to do is you see how it says if you give an x, we'll give you a y here. Well, so we actually like to write our machines as functions. So if you have this function machine right here, the inside is going to be this part right here, and we're going to let y equal that because whatever we get depends on x. And so now it's telling us find y if x is equal to -1. All right, and that's pretty straightforward, right? So we're going to say y is equal to 2 times -1 plus 5, right? Because x is -1, so we're plugging this in where x is. So that's going to give us 2 times -1, which is -2 plus 5. So -2 plus 5 is 3. So we get y is equal to 3. Right? That's not too hard. All right, so we're going to cover our last thing, function notation, and then we're going to call it a day. All right, so let's go on to the next slide. We like writing equations in the form y equals 9 minus 4, just like before. It has its uses, and you're going to see later on when we have when we start doing point slow form, that it's really cool and really important to have our functions written that way. But sometimes we like to use what's called function notation. All right, and basically that means, let's say we have this function right here, right? 9 y equals 9 minus 4x. We like to rewrite this. We like to rewrite this a certain way, and so what we can rewrite it as f of x is equal to 9 minus 4x. This part right here is read as f of x, and it does not imply multiplication. This is just another way to say y, right? And we like function notation because we can do things like this. All right, so this right here is, this in itself right here is the function notation. You replace y with f of x. And the thing we like f is because it says a function of x. You sometimes, and you can name, if you have multiple functions in a problem, you can have g of x, h of x, and then let's say this is equal to 3x, and you said this one's equal to 2x. Well, if I said f of x, we're talking about 9 minus 4x. If I were to say g of x, we're talking about 3x. If I said h of x, we're talking about 2x. So that's one of the reasons we like using function notation. But one of the main reasons we like using function notations is because we can do something like this. It says find f of 2, right? What does that mean? Well, what that means is when you have our original function is 9 minus 4x, right? This says evaluate f of x with x equal to 2. Or not with, at x equals 2, right? So we're saying we're gonna, wherever this 2 is, you're gonna plug in it. Wherever x is, you're gonna plug in a 2. So put a parentheses wherever x is. Okay, and now you're gonna fill everything in with a 2, right? And so f of 2 is now gonna be 9 minus 8. So we're gonna, I put x, f of 2. And so f of 2 is gonna give us the answer as 1. You might get some functions that look like this, and then for sake, I'm gonna write g of x because we're gonna use a different function. You might get something like x squared plus 2x plus 1. If they say find g of, I'm gonna use 0 for an easy number, right? G of 0. What that means is wherever our x is, you're gonna put parentheses, okay? And what's gonna go inside that parentheses? Our 0, the number inside, right? 0 squared is 0, plus 2 times 0, which is 0, plus 1 is going to give us 1. So g of 0 is 1. All right. So whenever you plug a number in here, whenever you plug a number for our x, you're going to replace all those values with x. Okay. All right. Other than that, that's basically it, guys. I know it's kind of a long lesson, but you know what? We're gonna push through. And if you have any questions, make sure to show up to the Zoom meetings. Bye bye.